Good afternoon, my dear friends. I am Mahinder Kumar, lecturer civil engineering from Government Polytechnic College, Batala. Today, I shall be discussing with you on the very important topic of curves from the subject of surveying 2 of 4th semester. So, curves are irregular bands provided in the lines of communications such as roads, railways and canals etc. to bring about gradual change of direction. So, we provide curves for bringing about a gradual change of direction in the means of communications like roads, railways and canals etc. Curves enable the vehicle to pass from one path on to another when the two paths meet at an angle. They are also used in the vertical planes at all changes of grades to avoid the abrupt change of grade at the apex. So, we mean that curves are provided in horizontal direction as well as in the vertical direction. In the horizontal direction, they are provided to bring about gradual change in the direction, and in the vertical direction, the curves are provided to bring about gradual change in the slope. So, horizontal curves, what are horizontal curves? The curves provided in the horizontal plane to have the gradual change in direction as already have been stated. They are known as horizontal curves which are provided in the horizontal plane to have gradual change in the direction. They are known as horizontal curves. So, what are vertical curves? Curves provided in the vertical plane to obtain gradual change in grade or slope. They are called as vertical curves. So, the curves may be circular or parabolic. Curves are generally arcs of parabolas. Curves are laid out on the ground along the center line of the work. So, please note that curves are laid out on the ground along the center line of the work. So, why we provide the curves? This is the need of providing curves. So, the curves are provided on highways, railways and canals for bringing about gradual change of direction of motion. They are provided for following reasons. Number 1 is to bring about gradual change of direction of motion, and second is to bring about gradual change in grade. So, these are two reasons. First is to bring about gradual change in the direction of motion, and the second is to bring about gradual change in the grade and for good visibility. Third is to alert the driver of the vehicle so that he may not fall asleep. So, if the road is a straight one, so there are chances that driver may fall asleep. So, that can be the reason for an accident. So, to alert the driver on an highway so that he may not fall asleep, we provide curves to alert the driver. So, fourth one is to lay out canal alignment. For a construction of a new canal and for making an alignment, we use curves. Fifth one is to control erosion of canals. To control erosion of canal banks by thrust of flowing water in a canal. So, if we provide curves on the canal, the erosion of the canal banks can be prevented. So, we provide curves to control erosion of canal banks by thrust of flowing water in a canal, because flowing water of the canal has a great thrust, and to prevent that we provide curves. So, how the curves are classified? Curves are classified on the following basis. First one is simple curve, second is compound curve, third is serpentine curve or reverse curve, and the fourth one is deviation curve. So, these are the four classifications of the curves, that is, we classify the curve in the following ways. First one is simple curve, compound curve, serpentine or reverse curve, and the fourth one is deviation curve. So, we will discuss one by one. First is a simple circular curve. You please see on your monitor screen, a simple circular curve consists of a single arc of circle connecting two straights. So, the A B and B C on your monitor screen, they are straights. So, a simple circular curve consists of a single arc of circle which connects two straights such as A B and B C. It has a radius of the same magnitude as is shown on your monitor screen in the figure. We have got R radius which is constant, and this radius is same throughout. It has got the same magnitude. So, this is the case of a simple circular curve. I repeat once again, a simple curve consists of a single arc of circle connecting two straights A B and B C, and it has radius of the same magnitude which is R throughout. Next, we have a compound curve. So, please see on a figure on your meter screen, we have got the figure of compound curve. A compound curve consists of two or more simple curves as is shown on your meter screen, having different radii bending in the same direction. That is, these two curves, they bend in the same direction, and it has got different magnitude of radius, and these curves or radius, they are lying on the same side of the common tangent. Their centers lie on the same side of the curve, that is the center of first curve O1. The center first curve has center O1 and it lies on the same side as is O2 of the second curve. So, I repeat once again, a compound curve consists of two or more simple curves having different radii bending in the same direction and lying on the same side of the common tangent. Their centers lie on the same side of the curve. So, the third one is reverse or a serpentine curve. We find such type of curves in our day to day life. You must have seen such type of curves. So, what is the definition of serpentine curve or reverse curve? A reverse or serpentine curve is made up of two arcs, as is shown on your meter screen. It has got two arcs having equal or different radii bending in the opposite direction. Please note, these radius are bending on the opposite direction and with a common tangent at their junction. So, a reverse curve or a serpentine curve is made up of two arcs having equal or different radii bending in the opposite direction with a common tangent at their junction. Their centers lie on the opposite side of the curve, which is this point is very important. Center O1 is on one side and center O2 of the second curve is on the opposite side. So, their centers lie on opposite side of the curve. Reverse curve are used when the states are parallel or intersect at a very small angle. So, this is the case where we provide reverse or serpentine curve, that is These are used when the straights are parallel or intersect at a very small angle. So, example is a level crossing. We find such type of curves provided over level crossing. So, this is the case of third one, reverse or serpentine curve. Next, we have the last part of the classification of the curve. This is deviation curve. So, a deviation curve, please see on your meter screen. This is shown in a figure on the left side of the screen. A deviation curve is simply a combination of two reverse curves. That is, we find here in the figure two reverse curves. It is used when it becomes necessary to deviate from a given straight path. That is, we see on our figure, we want to go in a straight path and we have to deviate our path due to a building coming in our way. So, it is used when it becomes necessary to deviate from a given straight path in order to avoid intervening obstructions, as is a building given in your figure, such as bend of a river, a building, etc. That is, when such type of obstruction comes in our way, we have to deviate from our path, then we provide deviation curve. So, these are four types of the classification of curves we generally use in our day to day life. Then is the figure showing on your meter screen. This is a diagram of a simple circular curve. We just have studied various types of the curves, and this is the first one, simple circular curve. You can see various parts of the curve on your meter screen. So, we find what are various parts of curve. First one is the two straights. The two straights, first one is A B. Just see on the cursor of the mouse on your meter screen. This is A B and B C, which are connected by the curve. They are called as tangents or straight to the curve. I repeat once again, the two straight lines A B and B C, which are connected by the curve, they are called as straights or tangents to the curve. Second part is the point of intersection, the point B on your meter screen. Please see the point of intersection of the two straights A B and B C, where these two straights meet or intersect. This is called as intersection point or vertex. This is called as intersection or vertex. That is the point B where these two straights A B and B C, they intersect. This is called as point of intersection or vertex. So, when the curve, third part is when the curve deflects to the right side of the progress of survey, it is termed as right handed curve. That is, we are going from A to B and the curve deflects toward the right side of the progress of survey, as is shown on your meter screen. This is called as a right handed curve. And similarly, when the curve deflects to the left side of the progress of survey, it is called as left handed curve. So, we find right handed curve and left handed curve when it is called when the curve deflects accordingly towards right or left of the progress of survey, accordingly it is named. So, fourth one part is the lines A B and B C are tangents to the curve. As I have already told you, the line A B and B C on your meter screen, please see to the meter. So, A B and B C, they are called as tangents to the curve. The line A B, it is called as the first tangent or the rear tangent. First tangent A B is rear tangent or first tangent, and B C is called as second tangent or forward tangent. So, A B is a first tangent or rear tangent and B C is forward or second tangent. The points T1 and T2, please see your figure on the monitor screen, this point T1 and the point T2. These are at which the curve touches the straights, touches the tangents or straights, they are called as tangent point. T1 and T2, they are called tangent points. The beginning of the curve, T1, the first point where the curve begins, is called as tangent curve point. I repeat it, the beginning of the curve, that is from where the curve starts, is point T1, is called as tangent curve point, and the end of the curve where the curve ends, the point T2, it is called as curve tangent point. Curve tangent point. Next is the angle ABC, the angle ABC between the lines AB and BC, as is shown on your monitor screen. This angle is called as angle of intersection, that is the angle between two straights AB and BC. Angle ABC, it is called as angle of intersection and is denoted by capital I, as is shown on your monitor screen. This is angle of intersection. Again, the angle by which the forward tangent deflects from the rear tangent, angle B dash, as is shown your monitor screen, angle B dash BC. This angle is called as deflection angle. The angle by which the forward tangent BC deflects the rear tangent AB is called as deflection angle, and it is denoted by phi. The distance from the point of intersection to the tangent point. Point of intersection, please see on the figure on your monitor screen, this distance BT1, distance from B to T1 or from B to T2, this is called as tangent length. It can be BT1 or BT2. The distance from the point of intersection to the tangent point is called as tangent length. Then the line joining the two tangent points T1 and T2, this line, horizontal line between T1 to T2, this is called as long chord. This is called as long chord. Again, the arc T1 F T2, this is the curved portion starting from point T1 F to T2. This portion is called as arc T1 F2 and is called as length of curve. The green portion, the curved one, the distance T1 F T2 is called as length of curve. Distance from T1 to T2, T1 F T2 is called as length of curve. The midpoint F, please see on your monitor screen, this point F of the arc T1 F T2 is called as summit or apex of the curve. This point F is known as summit or apex of the curve. The distance from the point of intersection to the apex of curve BF, the distance between B and point F, this distance from intersection and to the apex of the curve, distance BF, as is being shown on your monitor screen, this is called as apex distance. Distance BF is equal to apex distance. The distance between the apex of curve and the midpoint of the long chord, distance between EF, as is shown on your monitor screen, distance between the midpoint of the long chord and the apex of the curve E, this is called as EF distance, and it is known as worst sine of the curve. Distance EF is equal to worst sine of the curve. The angle subtended at the center of the curve by the arc T1 F T2. So, the angle subtended at the center of the curve by the arc T1 F T2 is called as central angle, and this angle phi, arc This angle subtended by this arc at the center of the curve is called as central angle, and this angle is equal to deflection angle phi. So, these two angles are equal. So, you just have gone through what are various parts of the curve. We have now the elements of a simple circular curve. So, what are various elements or various formulas we generally use while solving the numerical problems of the curves, or what are the relations between various parts of the curve. So, these are known as elements of a simple circular curve. Please see on your meter screen. First one is angle of intersection plus deflection angle, that is I plus phi. It is always equal to 180 degree, that is angle of intersection plus deflection angle, it is always equal to 180 degree. I plus phi, it is always equal to 180 degree, first one. Second element is angle T1 O T2, this is equal to central angle, and this central angle is always equal to deflection angle. I is equal to phi, 180 degree minus I is equal to phi. So, tangent length, distance from intersection of the two tangents to the first tangent point B T 1 or B T 2, and this is equal to O T 1 tan phi by 2, and it is numerically equal to R tan phi by 2, where R is the radius of the curve and phi is the deflection angle. Similarly, the formula for length of long chord, that is when we have to calculate the length of a long chord, we see on your figure, this will be equal to 2 times T 1 E, or trigonometrically it will be equal to 2 R sin phi by 2, where R is the radius of the curve. Next is length of curve. So, length of curve is length of arc T 1 F T 2, as it is already explained. So, this formula becomes pi R phi divided by 180 degree. So, you have to remember all these formulas or elements of a simple circular curve to calculate the numerical problems. Similarly, the apex distance becomes R versine phi by 2, and R is the radius, where phi is the deflection angle or central angle. Next topic is how we designate a curve, that is how we name a curve. A curve may be designated either by the radius or by the angle subtended at the center of the curve by a chord of particular length. So, that is we can designate the curves in two ways, either by radius of the curve or by the angle subtended at the center of the curve by a chord of particular length. In India, a curve is usually designated by the angle in degrees subtended at the center by a chord of 30 meters. Please note that in India, a curve is designated by the angle in degrees subtended at the center by a chord of 30 meters or 100 feet length. This angle is called as degree of curve. So, please remember, in India we designate the curve by the angle subtended at the center of the by a chord of 30 meter or 100 feet, and this angle is called as degree of curve. The degree of the curve indicates the sharpness of the curve, that is how sharp our curve is. In English practice or in English country, a curve is defined by the radius of the curve in terms of chains. You have studied chains in the last semester, such as a 6 chain curve means a curve having radius equal to 6 full chains, a chain being 30 meters unless otherwise it is specified. And in America, Canada, India and some other country, a curve is designated, as I have just explained, by the degree of the curve. For example, a 4 degree curve means a curve having angle of 90 degree at the center subtended by a chord of 30-meter length unless otherwise specified. Next we have relation between radius of curve and degree of curve. The relation between the radius and degree of the curve may be determined as follows. Please see on your monitor screen a diagram showing the degree of the curve, where r is the radius of the curve in meters, d is the degree of the curve, and mn is the chord of 30-meter length, p is the midpoint as is shown on your meter screen. So, in triangle OMP, OM is equal to r and MP becomes half times of MN is equal to 15 meter. So, sin d by 2 becomes 15 by r, and we develop r is equal to 15 by sin d by 2. So, this is the relation, but where d is the small, sin d by 2 may be too small and approximately equal to r will be equal to 1718.87 over d, or we can say r is equal to 1719 by d, and this is the relation between the radius of curve and degree of curve, and this relation holds good up to 5-degree curves. For higher degree of curves, the exact relation, that is r is equal to 15 by sin by d by 2, that can be used. So, now we have methods of curve arranging. A curve may be set out, or how we can set out the curve by linear method where chain or tape is used, and by angular or instrumental method where a theodolite with or without a chain is used. So, how we arrange a curve or set out a curve? Before setting out a curve by any method, the exact positions of the tangent points between which the curve lies must be determined. Following procedure is adopted. What is the procedure? After fixing the direction of the straights, produce them to meet in point B. Set up the theodolite at the intersection point and measure the angle of intersection I. Then find the deflection angle phi by subtracting I from 180 degree, that is phi is equal to 180 degree minus I. Next, calculate the tangent length BT1 or BT2 from the following relation. Tangent length is equal to r tan phi by 2. Next, measure the tangent length BT1 backward along the rear tangents BA from the intersection point, thus locating position of T1. So, similarly, locate the position of T2 by measuring the same distance forward along the forward tangent BC from B. After locating the positions of the tangent points T1 and T2, their changes may be determined. The change of T1 is obtained by subtracting the tangent length from the known change of the intersection point B, that is this change is known, and the change of T2 is found by adding the length of curve, we just have studied the formula, to the change of T1. Then the pegs are fixed at equal intervals, generally 30 meter. So, the interval between pegs is usually 30 meter or one chain length. This distance should actually be measured along the arc, but in practice it is measured along the chord, as the difference between chord and the corresponding arc is small and hence it is negligible. In order that the difference is always small and negligible, the length of the chord should not be more than 1/20th of the radius of the curve. The curve is then obtained by joining all these pegs we have just fixed. The distances along the center line of the curves are continuously measured from the point of beginning of the line up to the end. That is, the pegs along the center line of the work should be at equal interval from the beginning of the line up to the end. There should be no break in the regularity of their spacing in passing from a tangent to a curve or from a curve to the tangent. For this reason, the first peg on the curve is fixed at such a distance from the first tangent point